A force F of minus 8I minus 10J newtons and tension T 24I plus 18J newtons acts on an object of mass of 4 kilograms. Find the acceleration of the object. Given that the velocity is initially at rest at the point with position vector 2I minus 3J meters, find the displacement after t seconds, and then find the acceleration and speed of the particle after 3 seconds. Okay, so if we look for the resultant force of these two, so as they're in vector form, all we need to do, and I like to use column vectors, so I'm going to write minus 8 minus 10, and add to it this tension here, which is 2418, and get a resultant of 1648. And then using Newton's second law, F in terms of vectors is equal to mass times acceleration. Force and acceleration are vector quantities. Then we're going to have 16.8 is equal to the mass, which is 4, times the acceleration, and therefore we're going to get the acceleration is going to be 1/4 of 1618. Therefore it is 4.2 meters per second squared, or 4I plus 2J. Right, notice there's no t in this, so therefore it is a constant. So if it is a constant, we can use Suvat equations. So if we now use S as displacement is equal to ut plus a half at squared, then as acceleration is a constant, we can use it. The initial velocity is 0, and therefore we can say that S is 0 times t plus a half times 4.2 squared, which will give it in terms of t of half of 4, which is 2, t squared, and half of 2 is 1, so we're just going to get t squared. But we were told the initial position in the question is 2 minus 3, and therefore we need to rewrite this, taking that into account. So we need to put 2 plus 2t squared, and then minus 3 plus t squared meters. And usually we use r for displacement when we're talking about vectors. C, if we use now that v is equal to u plus at, again we can use that because we've got constant acceleration. The initial velocity is 0, and the acceleration is 4.2 from up here, times t, and therefore we want, that will give me 2t meters per second. And then when t is equal to 3 seconds, we're going to get that the absolute value, which gives me the actual magnitude of the acceleration. So the absolute value of the acceleration will be 4.2, so that's just going to be 2√5, or 4.47 meters per second squared. If we now want the speed, so when t is equal to 3, we substitute it into this, we're going to get 4 times 3, and then 2 times 3, which was going to give me 12.6 meters per second. That's the velocity vector, so in order to get the speed, we need to find the magnitude of that, which is 12 squared plus 6 squared, taking the square root of, which will give me 6√5, or 13.4 meters per second. Okay, this has been a video to show you how to find displacement, velocity, speed, and acceleration using Suvat equations and using vectors in 2 dimensions. I hope you've understood, and I thank you very much for watching, and if you'd like the video, maybe you could consider subscribing to my channel. Thank you very much.